Today on our podcast, we have Mark Hoffman. He and I met back in Chicago days in Chippy, and he's moved all the way through several positions doing machine learning and data science, and now landed himself a position at the Jet Propulsion Lab from NASA. Welcome, Mark. How you doing today, Mark?
Doing pretty well. Thanks for having me on.
Hi, Mark. How are you doing?
Hey, pretty good. Glad to be here.
Why don't we start off a little bit about your progression? You're now at NASA, is that correct? And tell us how you ended up there.
Yeah, sure. So, this is actually a very interesting, story with a lot of twists and turns. But I originally started out in undergrad as a physics and math major. Doing a lot of that stuff. I was physics, math, and a little bit of pre-med there. Did the whole MCAT thing. I ended up deciding that I didn't really want to go down the route of being a doctor after a couple internships, and the whole doctor route seemed a little depressing. So also while I was in undergrad, though, I was working in a nuclear physics lab where we were doing a lot of data analysis of nuclear physics experiments that were run up at Michigan State University. I went to Augustana College in the Quad Cities on the border of Illinois and Iowa, but the professor there had a very close tie into Michigan State. And so he always brought a lot of the research work back there. And so that was probably my first time touching data in any real sense. But so essentially, once I got to the point of deciding that I didn't want to be a doctor, I was looking around for different types of grad programs I could apply all this like physics and math knowledge to. And at that time, the whole like data space started to really ramp up. That was right around the same time that the AlexNet deep learning paper came out, and people were starting to recognize a data scientist as something that could add like immense amounts of value. And so I ended up finding this grad program out in North Carolina at the North Carolina State Institute for Advanced Analytics. And essentially, it was like a master's of analytics, data science, going through all the statistical modeling, machine learning types of knowledge. But essentially there, I learned like essentially all the modeling skills, all the data management skills. I was working with a government agency at the time as well as part of that graduate program where I was able to sort of see how data science works in real life at the business government level. And after grad school and having that experience in government, I essentially decided to hop off the corporate bandwagon and go straight into startup mode. That's when I moved back to Chicago. I had previously been doing a lot of sort of like freelance work with other friends that I had in undergrad at the time as well. We started sort of like my junior-ish year of undergrad, just doing these like one-off platforms or one-off like website designs for people. But essentially, moving back to Chicago, we decided that we were going to build larger scale software applications. And so that's just what we did. Our like first application was like in the transportation logistics space. We've done a lot of stuff in like construction as well and real estate as well. But essentially all these different software platforms had the idea of integrating data and making data useful in an automation sense to a number of different businesses that traditionally have been very traditional in their operations and didn't really have much technology infused in them. But essentially through there, we had a lot of success through these different software platforms, learned a ton of stuff going through essentially the whole knowledge cycle of trying to set up like our own servers for hosting on like DigitalOcean, setting up our own load balancers, all the way through like becoming very well versed in AWS. But then, yeah, we had a lot of success at that point. We ended up, or then from there, I ended up doing some work at Blue Cross Blue Shield, downtown Chicago. I was helping them in a data science machine learning group who was focused on a wide spectrum of problems there. Like one of the big problems was optimizing PPO groups for physicians. And as part of that, we had to measure risk associated with patients by looking at claim data. And so there's a lot of risk modeling there, more of your traditional machine learning, traditional structured data sense of things. But then I was also involved in an anomaly detection project as well, looking for fraud, waste, and abuse cases from physicians for the different claims being submitted. Um, that part was actually I was delving into a lot of the newer types of like neural network based deep learning techniques for time series modeling. So at that time too, there's a lot of work in deep learning around unstructured data, right? Around like images and not really as much text at that time. Although text is like blown up a ton now. But I was specifically focused on structured data problems with deep learning time series. But it just so happened to be that I had a colleague as well that was working at the NASA's Jet Propulsion Laboratory, where I am right now, who he was working on a very similar problem, but related to spacecraft telemetry data. And the whole idea was you have the spacecraft who has thousands upon thousands of telemetry channels, and traditional anomaly detection methodologies were essentially just setting threshold alarms for those different telemetry channels. And you'd end up with this case where, because the state of the spacecraft changes so often, you'd end up with a ton of false positive alarms, and essentially the operations engineers become desensitized to those alarms. And so what he was doing, which directly matched up to all of my fraud protection stuff at Blue Cross, was dynamic time series models in order to adjust to the current state of a given system of structured data. And based on the dynamically adjusting your model to that state, how do you predict anomalies and drill down into reasoning from those? And so, yeah, I hit it off with him, and I ended up making the move down to Pasadena about it's about a year and a half ago now, in April of 2018. And since then, I've been working on a number of different projects spanning AutoML, uncertainty quantification, optimization for the deep space network. Yeah, a lot of very interesting things down at JPL since then. But yeah, that's sort of the high level journey of what I went through. A lot of twists and turns, got my hands dirty with software, machine learning, deep learning, statistics.
So, Mark, Brian will probably get deeper into how you actually deploy and practice deep learning and AI. I'd like to take you back to First Class Technology Corporation, which looks like from your LinkedIn you successfully sold. So, congratulations on that. I mean,
Thanks.
that's not easy to do with your first startup for sure. Most people don't get that far.
Mm-hmm.
Now, in the description, it covers a lot of different categories. You go from luxury brand engagement to consumer insights for corporate entertainment, hospitality, and event industries, for example. Maybe explain a little bit about the relevance there from setting you down into deep learning. Um,
Mm-hmm.
what's available now? Maybe share how you would have done that startup differently.
Sure. So yeah, when we started First Class, the whole premise and idea was essentially trying to infuse modern technology into an industry, into this black car luxury transportation industry, whose tools for the most part were still in an era much before now. So like you walk into one of these buildings and everyone is still making phone calls for all the operations. People are writing a lot of day-to-day operational items down on a piece of paper and passing these pieces of paper around to each other. So the first step that we tackled was essentially trying to modernize and automate every single piece of the daily operations of these luxury transportation companies.
Before you get into what you would do differently now with the tools you work with on an everyday basis, it sounds like you were like 5 to 10% away from being Uber, though.
To an extent, so like what we were doing was we were still keeping a lot of human in the loop, and that's a theme that you'll see, like especially like human in the loop for machine learning and like AI applications. You'll see that come up like all the time. Versus we didn't necessarily have the resources, especially being like a first startup, not really super well funded. There's a lot of the sort of like sweat equity type thing of putting in the very, very long hours every week. Um, because we didn't necessarily have those resources that like Uber and Lyft could afford in terms of either just like giving away giving away subsidized products, um, or just like build up enough data. We really had to keep the human in the loop for the majority of the technology operation. So like we still have a dispatcher. The dispatcher would essentially be able to automate 80% of his job, so he could uh, expand essentially the efficiency of the logistics company by a decent amount.
The kind of question I have for someone who's at NASA is how much can the human be in the loop in some of your cases that you're talking about, and how does that play into when you're talking about putting something into space?
Yeah, I mean, at NASA, there's a number of different use cases that I'm actually currently working on. That no matter how good the machine learning and the AI gets, um, there'll always be some domain knowledge that you have to have a human loop. One great example is I've been working on a deep space network scheduling research initiative for the past year or so. Essentially, the goal is, or let's back up to give you a little bit of background. The Deep Space Network is comprised of three different uh, three different locations around the world. One's in Goldstone, California. One's in Madrid, Spain, and one's in Canberra, Australia. The idea is to have them on uh, very different sides of the world, so that as the Earth spins around, you can have optimal coverage to any number of spacecraft that you have flying. The current process of the way that it's been operating for the longest time is very based off of heuristics. And those heuristics might be uh, everything from let me see where all these antennas, like as the antennas are rotating around, these spacecraft are only visible during certain periods of time. So let's just start a sort of first in like a first in place a requested track onto that schedule, then go all the way through, and then go through a couple of heuristic methods to try and resolve conflicts. Or maybe if missions requesting like an 8-hour track, you can split that into two separate 4-hour tracks on two different antenna. Um, we're trying to move from that much more to an automated methodology where maybe heuristics can get us to 60%, with the last 40% having to be very human intensive involved for uh, splitting up the schedule and making sure the missions that required the amount of resources if they're at a critical stage in their mission, as opposed to possibly just a spacecraft uh, that's just en route and you just have to make sure it's still alive, but it has a couple of years to get to its destination. Um, those types of like mission priorities are very hard to model within any sort of like optimization framework. So like maybe a heuristics based approach, which could get you to like 60% before, we're trying to take some of these more modern machine learning techniques and take that 60% to maybe like a 80, 85, 90%, and then have that last little bit be the human loop of knowing that a particular mission is might be having trouble with a certain subsystem on a spacecraft, and they need extra time, extra telemetry to sort of diagnose what's happening, or a mission might be in a critical state.
In my opinion, I always thought of NASA back in the '60s and the place where everybody wanted to work, right? I mean, every every young man, my dad's age, was born in the early '40s, wanted to work at NASA. Um, and what is the challenge? What is the one day when you're like, man, this is hard? Or have you ever regretted it, or do you just love every moment of it?
um, I do love every moment of it. There's a lot of very interesting projects. The one downside to that is though there are just so many interesting projects, right? And so while I could spend like all of my time just really really digging into this like DSN scheduling problem, for example, I'm also being pulled on a number of other projects for certain skill sets, and it becomes this thing of there's so many things that that you want to do and that are really really like important for you to do, but it's sort of tempering that down, controlling what your focus is on.
And Mark, that sounds like there's a resource problem in terms of there's not enough talent at NASA with your type of experience or skill sets.
I'm actually part of a new group there as well. So the group that I joined is called the IEC, or the Innovation Experience Center. We sit directly underneath the Chief Technology and Innovation Officer of JPL. And I think the group is only 3 or so years old, and it started out with like 1 or 2 people. But to sort of give you a frame of reference of how important these different like new data science and AI techniques are for Earth science and for all space exploration in general. Our group of like 1 to 2 people 3 years ago, I think we just crossed like 19 people or 20 people in this sort of co-located area that everyone's sort of a general purpose data science, deep learning, cloud engineer, software developer, but all with some sort of focus in bringing data into being useful in different applications. So yeah, the need for the skills are expanding drastically, and I mean that comes from compute getting much better and just these different techniques continually getting better and better every year.
And do you believe it's moving in the industry overall, not just at NASA? Do you ever believe that it's moving too fast, or what are the precautionary tales? I always do this, man versus machine, machine versus man, versus machine analogy here. But is there any precautionary? What keeps you 19 in check after growing at such a quick pace?
Even if you look around in the industry and there's this huge theme that keeps going around of ethics for essentially anyone that has the power of or has the skill set of um, creating algorithms on top of data to then be placed into automated systems. Right? You'll see a ton of speakers that keep emphasizing how important this is, and it really is. So look back into, I think it was January or so of this past year. OpenAI, they released one of their language models called GPT-2. But so it was actually sort of funny. The way they released is they had this blog post and essentially went down and it says like, oh, like we came up with this new architecture trained on like hundreds upon hundreds of GPU hours, and it destroys the state of the art for a number of these different language tasks, neural network based, everything. But what they did was at the end, they're like, oh, so this works really, really well, but we don't want to publish the model open source yet. Even though up to that point, they've been publishing everything open source that they've been doing. But really their reasoning was the technology of deep learning applied to especially in the vision and language domains has been accelerating so much over the past couple of years that the essentially defensive measures, it seems like defensive measures haven't had enough chance to really be built up against this. So their reasoning was a bad actor could come in, and these models are very good at language generation. What happens if a bad actor comes in and knows just enough to essentially create automated software to disseminate disinformation on a massive like DDoS style attack, right? So like, what are you going to do to try and combat that? And so like it comes sort of with a double-edged sword of the people who are building these algorithms. They have the opportunity to have massive influence on essentially any domain, any industry that they want to. But there's a lot of ethical concerns of should these algorithms really be being put into place in the specific domains without proper checks associated with them. And so another big thing associated with this is you can think about like image computer vision models being biased towards people of minority backgrounds, and this sort of gets back to like what kind of data was it trained on? Is this going to be placed into a setting where say computer vision model is biased towards minority backgrounds, you're and it's used to detect the police or contact the police if it sees suspicious activity. So now you're just encouraging a system that potentially already has biases, and there's a lot of scary feedback loop situations that I think people building these algorithms have to be cognizant of, um, in order to get these models out in a responsible way.
Brought up kind of a very malevolent example of somebody deliberately acting um, in an unethical way. However, these algorithms often reflect the authors and their experiences, their tastes. Um, is there a challenge in in your workplace at NASA in recruiting a diverse um, set of practitioners so that there is some involvement of a diverse viewpoint and diverse experiences as humans?
Yeah, definitely. So that's actually one of my favorite parts about working at NASA and JPL in particular. I've never been in a place with so many international and foreign nationals working alongside, from all different cultures. So um, yeah, I mean, in the past like year and a half, I've done everything from I had it's like sort of funny, but I had like Indian food for the first time with people who there's a lot of people who uh, came over to the United States for university from India. I know some people who immigrated from Armenia that I work very closely with. Um, there's such a wide range of backgrounds and cultures that uh, they definitely try and get that diversity implemented there, and that's something that yeah, I mean, even in my experiences back in Chicago, that just wasn't the case. It seemed like there's a lot less emphasis on that, um, but it really does make a huge difference in terms of problem solving, in terms of making sure you're thinking about potential biases and like what type of data you're using. And another note uh, on sort of like the defensive side of AI and where it's at with um, like we were talking about like what happens if a bad actor gets a hold of a text generation model or possibly a computer vision GAN model and start generating fake disinformation, or people want to affect the like validity of like supply chains and insert like counterfeit electronics, which is a very real challenge for a number of organizations that depend very heavily on the validity of their supply chains for electronics. There's actually a really big DARPA initiative that I've been fortunate enough to be able to uh, start getting involved in, or try to or there's a DARPA project that's getting kicked off. Um, I think it's next year, but they just had the entire proposers day where there's a lot of DoD money actually being pumped into methodologies and defensive measures to try and identify disinformation and fake content that's being generated from some of these methodologies. So, for example, there's one called Semaphore. It stands for semantic forensics, and where sometimes when GANs generate images, one of the popular examples is it'll give a different type of earring for one side of someone's face to the other side of someone's face. But that's something that most computer vision models wouldn't necessarily pick up on. So the whole project is around featureizing different components of text, of images, and finding discrepancies in between multimedia image sources in order to build defensive mechanisms that adapt continually to this sort of threat that's definitely very real in the world we live in
So
today.
that's very much the future, I think. And I was going to ask that question: is what did you see in the future? But in the interest of time, we want to keep this to our 26.1 minutes. Um, are there any closing ideas of that you'd like to state regarding the state of AI and the future in NASA, and any last memories you want to leave the audience?
Yeah, so I mean, in terms of like data science and AI as it relates to like JPL space business, it's definitely a really exciting time to be in this space. If you have these types of skills, you definitely have a lot of you definitely have a lot of power to be involved in essentially shaping the next generation of the way people do business. That's definitely very exciting. So.
That's a wrap. Thank you for joining us on AI Podcast. You can reach us at ai-podcast.com or find us on Spotify or iTunes. Thank you again, and we'll see you soon.